How is this different from this? First of all, there's two equations, right? There's only one here. What else is different here in this section than in this section? There's no y on this. There's only one letter. This is one letter. One dimension. If we graph the answer to this, it would be one single number, wouldn't it? If we solve this for x, wouldn't it be 2x equals 6 and x equals 3? So this is the solution right there. Just a single number, right? If we graph these two, wouldn't it be two lines? You graph those in two dimensions because there are two letters. There are two letters. Okay? So back in the beginning, Algebra 1, we had one letter. And then we had two letters. Okay? One dimension, two dimensions. So this is the system that we're looking at. Your answer is going to be where these two lines cross. Okay? And that's what we're talking about today. This is the introduction to that particular section. Questions? Let's go to, so when we find the values of x and y, we find the answer. And the answer is written as an ordered pair, x, y. The values of x and y must be true for both equations. So when we plug them in and we test to see if it's true, if it's not true for one of them, it's not a solution to the system. So it has to be true for both of the equations. Now, there's actually three ways to solve a system of equations. One way is to graph and look for the point of intersection. Okay, for example, if we were graphing these two equations, which is why we reviewed graphing so much in the beginning of this class, we would solve for y. So it's negative x plus 5. So I would graph this one by graphing the y-intercept 5 and the slope of negative 1 for this line. Okay. Then I would graph the other one on the same grid. So this is negative y equals negative x plus 3. And as we just reviewed, you need to divide everything by negative 1 here. So y equals x minus 3. Everything changed signs. So this is negative 3. And the slope is positive 1. So up 1 over 1. And so my line, trying to make it green, is going to look like this. Still going to make it green. But you can see that these two intersect right here. So that is the point of intersection. And it represents the solution to the system of equations. So you can see that x is 1, 2, 3, 4. and y is 1, making the ordered pair 4, 1. All right, moving right along. Example 2. Let's find the solution to this system. What we're going to do is solve both of the equations for y, graph them on the same grid. So I'm recording this video for the absent people, so I'm going to pause it right now while we wait. Oh, I better stop. Okay, now that we've graphed these, now that we've solved these for y, we're going to graph them. So let's do the red one first. Negative 2x minus 5, so the intercept is negative 5. And the slope is negative 2, up to left 1. So my line for this one, let's see if I can make it red. It's going to be here. Didn't make it red, did it? And that's a little off, so let me see if I can adjust it. It's much easier to adjust it over here. Okay, so there's our line for the red one. Let's see if we can get rid of this extra piece. Not over here, right? Let's try the blue one now. So the y-intercept is 1. So that's right here. And the slope is 1, so up 1 over 1. So let's graph that one. Trying to make it blue. We'll see what happens. And so this is going to be here. So the solution for this one is this spot here. And so x is negative 2 and y is negative 1, so the solution is negative 2, negative 1. So the answer is no, they will not cross it again anywhere else. But you do need to make your lines very accurate, use a straight edge. Okay, so let's take a look at the next one. Number 3. We're going to graph these two. The first one in number 3 is already a y-intercept form. So all we need to do is to graph the y-intercept at 5 and use the slope of negative 1/2 to draw our line. Let's see if we can make this. So there's our graph. Y equals negative 1/2 x plus 5. Now let's graph the second one. And in order to graph the second one, we need to solve for y. So 4y equals negative 2x plus 8. Divide both sides by 4, so y equals negative 2 over 4x plus 8 over 4. Yes, you have to divide both terms by 4, but just like I did on our example in the very beginning of class, I'm going to reduce this one to make it easier to count on my graph. So y equals negative 1/4 x plus 2. So always simplify, and that makes it easier to graph. So my y-intercept is 2. So there's my y-intercept. And the slope is 1/4, but it's negative. So go up 1 and left 4. So there's my graph there.
You can go down 4 and right 1.
I could go down 1 and right 4, and this point will also be on my line. Okay, so this is supposed to be a 2. because 2 over 4 reduces to 1/2. So let's try that again. The intercept is still at 2, but the slope is 1/2. So up 1 and over 2. Up 1 and over 2. So what are we seeing about this graph? It does not intersect. Why doesn't it intersect? They are parallel. Do you see these lines are parallel? So since these two lines are parallel, there is no intersection. And so do you see this right here where it says write no solution? If, I know, I didn't mean to do that. If you see that there is no solution,
Zoom in a little bit.
it's on the paper in front of you.
Don't like the dots.
And we have no solution. Because we know that parallel lines never cross. So if these never cross, there will be no solution. Okay? So we need to graph these two. The first thing you want to do is to solve for y. So pause the video. So solving this one. Negative 2y equals negative 6x plus 10. Divide by negative 2. Negative 6x over negative 2 plus 10 over negative 2. So y equals 3x minus 5. Now let's do the other one.
See the intercept?
And see the intersection.
What's the difference between intersection and intersection?
Intersection is in football. You catch Divide both sides by negative 1. And so this one has an intercept at negative 4. Intersection at negative 4. And 2, 1. So here's the line on that one.
Wait, how was that?
So as you graph these, the intersection is here at 1, negative 2. We want to graph these two. So the hint I have for you is to set these equal to y, graph them both, and let's see what the intersection is. So if you're watching the video, pause it. These two. What do you notice about these two? Do you see that this is exactly the same as this? What does that mean? Okay, and here's the third possibility. Remember I told you there were 3 possibilities? 1, there's one intersection. 2, there's no intersection. And 3, there is so many intersections you couldn't possibly list them all. Isn't this the same line? If they are the same line, they are co-linear. And the answer then is that there are infinitely many solutions.
You want us to write that?
Yes, that's the answer to that one. Why are there infinitely many solutions?
Because if you keep going up.
Because one line is right on top of itself, the other line, right? And so there are a number of intersections, so many intersections that you can't count them all. So we solved the second one for y. So the first one is 5, and it's a negative 1/3. So rise 1, left 3, and here's my line. And for the second one, it's down 1, and the slope is 3. So rise 3 and run 1. So the line on the second one looks like this. So you can see the intersection to this one is 1, 2. No, 1, 2, 3, 4. 1, 4. Okay, finally, let's try this one. 3y equals negative 3x minus 3. Divide everything by 3. Y equals negative x minus 3. So, these two are going to be parallel. And we know that these two are parallel because you can see that the slope in this one is negative 1 and the slope in this one is negative 1. So when the slopes are the same, if the lines are parallel, then they will never intersect. And there is no solution. So we don't even really need to graph this one to figure that out. But let's go ahead and graph them just for good practice. The first one has an intercept at 2 and a slope of negative 1. So here's the line for this one. And the second one has a slope of intersect of negative 3 and a slope of negative 1. So there's the line for this one. You can see that those two lines are parallel and they will have no intersection. Lines are parallel if they have the same slope. Lines are parallel if they have the same slope. And different y-intercepts. If they have the same slope and the same y-intercept, they're collinear. And so there's so many answers you can't count them all, or infinitely many solutions. So let's graph these two equations. So you can see for this one that we have the same slope and the same y-intercept. So there are infinitely many, infinite points of intersection. Lines coincide and if they have the same slope. Let's mark this out. If they have the same slope and y-intercept. Okay? All right, that's going to do it for our notes. I know there's a couple more things down at the bottom. What I want you to do is to answer those two questions and see if you can answer them without graphing. See if you can answer them with their. Here was our agenda for today. We turned in our 3 warm-up questions. We completed our notes on systems of equations. These are posted online. With this, your staying class activity is due by the end of class on Thursday. You'll have a little bit more time to work on it, but we have to cover direct and inverse variation. And finally, your Unit 5 IXL assignment, the first Unit 5 part is due next Friday.